Hi viewers, welcome back to my channel and I'm here with another video. In my previous video, we have discussed about the actuator and weight gate of the turbocharger. But in today's video, I'm going to talk about in detail about the turbocharger. What is turbocharger and how it works? So let's start. So first, what the turbocharger is. What turbocharger is? The turbocharger is a forced induction device that compresses air entering the engine, allowing more oxygen for combustion. More oxygen means more fuel can be burned, resulting in a higher power output without increasing engine size. Now I discuss about the key components of the turbochargers. Number one, a turbo housing, drive by exhaust gases. Compressor wheel forces air into the intake. Number three, center housing, contain the bearing and lubrications. Number four, waste gate, control boost pressure. For detailed components, you have to watch this video which I recorded for you. So here you can see I have came to the engine, and this one is my turbocharger. You can see, so I'm showing to its different components. So first of all, this one is a actuator, and in this area is its waste gate, and this is a outlet, exhaust outlet, and here is a compressor, and in this area is a turbine. Okay, so this side goes to the muffler. You can see here is the muffler. So gases are exhaust gases goes out, and in this area here is a inlet, air inlet. Air enters to the this turbine, this compressor. Here is you can see the cleaner, air cleaner, and is coming down airs here, entered here, and this, and air enters his compressor, compress the air, and you can see this compress, and this is air pipe goes to the intercooler. Okay, enter the intercooler here, and this hose, this is for lubrication. You can engine oil coming from the engine oil is coming here for lubrications, and this is coming this is a water hose is for come to cool this exhaust. You can see here is this is a water pump. Here is a water pump is here. Okay, and water is coming to here to cool this turbocharger. So this is my intercooler out. Okay, after cooler is here when entering from the air here, and here is a intercooler, and this air is coming out to this house. And this house here you can see this one, this is my preheating coil is here. This is again giving the heat to the air, and if there is any moisture, that moisture is dried and it goes to my inlet. Okay, you can see this is my inlet. So air is entered to the manifold, inlet manifold from here, and just show you later. This you can press. This is a sensor. This sensor is measuring the temperature and pressure of the inlet air. Now we talk about the common failure. What are the common failure of turbochargers? Number one, oil starvations. Why oil starvation? What happened? Clogged oil feed lines and bearing can failure. Number two, over boost. Why over boosting? Waste gate failure and engine can be damaged. Number 3 is common failure is a carbon build. In carbon is built inside the turbocharger. Why carbon build? Poor maintenance, stuck the vanes. Number 4, boost leak. Why? Cracked pipe, intercooler, low power. So these are the common failure of the turbochargers. Now at the end, we will talk about how turbocharger works. So how turbocharger works, you have to watch this video. This video I have checked on the YouTube's and I checked this is a very excellent animation video. So you have to watch this video and you can see how turbocharger is working.
How does a turbocharger work? Air can either enter the engine under the influence of atmospheric pressure at the moment, when the piston moves and increases the volume of the chamber, or be supplied with the help of a special compressor. In the second scenario, there will be more oxygen in the engine, and therefore it will be able to produce more power. An impeller compressor wheel is installed in the compressor. When rotating, the blades of the impeller force air to move. Air particles are pushed to the perimeter of the impeller and enter the volute, from where the compressed air flows out of the air outlet of the compressor and then moves on into the engine. In order for the compressor to force air into the engine, the shaft on which the impeller is mounted needs to be rotated. There are various ways this can be organized. The first way is for a pulley to be installed in the engine shaft so that a belt drive can transfer the rotation to another pulley mounted on the compressor shaft. The second way is called turbocharging. It is based on the utilization of residual energy from the exhaust gas flow. For this energy to be used, a turbine is necessary. Inside a turbine, the opposite happens. The moving gas causes the wheel to rotate. The turbine wheel can be installed in such a way in the exhaust system of the engine that the moving particles of gas will act upon the blades of the wheel. As a result of this action, the wheel will rotate. Then, if the turbine wheel is connected to the compressor, this creates a turbocharging system. In this case, the compressor wheel will be made to rotate by the turbine. So, how does an entire turbocharged engine work? First, the cylinder is filled with a mixture of fuel and air. When the preset compression ratio is reached, the mixture ignites, expands, and causes the piston to move downward, rotating the crankshaft. The exhaust gases are then forced out of the cylinder by the piston and move towards the turbine. The particles of gas act upon the blades of the turbine wheel, causing it to rotate. The turbine and compressor wheels are mounted on one shaft. When the turbine wheel rotates, the compressor wheel also rotates, forcing air into the engine cylinders. The exhaust gases have a very high temperature. They heat up the turbine, and from it, the heat is transferred to the compressor. In addition, as air is compressed, it also heats up. When heated, air expands. Thus, what happens is that the compressor compresses the air, but at the same time inevitably heats it, and so, the air expands once again. This process is inefficient. For this reason, the air exiting the compressor's outlet needs to be cooled. An intercooler is used for this purpose. An intercooler is a heat exchanger. There are two types of intercoolers, air-to-air and air-to-water. The manufacture and operation of a turbocharger is costly. When a turbine is used, the back pressure in the exhaust line increases. But the benefits of the additional power from using a turbocharger can be much more significant than the associated costs. Turbocharging is most effective in high-power engines, but recently it has also been used in low engines to make them budget and environmentally friendly.
I hope now you have complete understanding about the turbocharger. If you found this video is helpful, so press the like button and subscribe to channel for more informative videos. Thanks for watching. See you next video.